and welcome to this video on hybridization. This is for the lower middle six, the wonderful lower middle six. So we're continuing our journey along hybridization. Okay, and what we did in class the other day were the shapes. So we understand the shapes. Now the ones we're specifically concerned with hybridization are the carbon compounds. Okay, so we're interested in those and the shapes of those. Now, carbon can basically form these shapes. It can be a tetrahedral. It can be a trigonoplanar, or it can be straight. I don't think, unless I'm missing one, I think that's about it for carbon. Okay, so this is a tetrahedral. This is trigonoplanar. And this one is linear. Okay, so an example of them all here. Let me see if I can think of an example. Methane. That's a good example of tetrahedral. Squashed it in there. Trigonoplanar would be an aldehyde or a ketone group. And linear is carbon dioxide. Another nice linear one is a nitrile. Okay, so they're the three configurations around carbon. Now, and these are the shapes we talked about in class. This is the molecular geometry, isn't it? Molecular geometry. Now, how do we sort of marry, as it were, the molecular geometry to the hybridization? Well, like this, I'm going to show you. All right. Excuse me. Right, now, you should have all remembered, if you have 2s and 3, let me just draw this so you'll see what I mean. 2s2, 2p2. Okay, that's 1. 2s2, 2p2. This is the other one. And I'm repeating myself on purpose here, right? 2s2, 2p2. So at the moment, all of these are the same. Okay, so let me label them. This is 2s. This is 2p. This is 2s. This is 2p. Now, if these hybridize, you're going to get 4. If the 2s's and the 2p's merge together, you're going to get 1, 2, 3, 4 hybrid orbitals. And 1, 2, 3, 4. Okay, let me do promotion first because I think I've missed out a step, haven't I? So first of all, we're going to promote that. So we're going to get the S, 1, 2, 3. This is the promotion stage. And the promotion stage here looks exactly the same. And the promotion stage looks exactly the same there. So 1, 2, 3, 4. 1, 2, 3, 4. So all I've done is I've promoted one of the S's to the P. Okay, and this stage is known as promotion. So there we go, we've promoted. And then we get hybridization. All right, and now in this case, the S has merged with the 3 P's, and we're going to get sp3 hybridization. In this case, the second middle case, we're going to get the S is going to merge with 2 P's only. So we're going to get 1, oops, wrong color. Let me try and be consistent. So we're going to get 1, 2, 3, and one of the P's is not going to get involved in the hybridization. So 1, 2, 3, and this guy here is the P. So these are going to be SP. Ooh, wrong color again. What's wrong with me? All right, there we go. Let's try and keep consistency. These are SP2s because 1S and 2 P's merged. And this is the P. This doesn't want to get involved. And the other case is when 1S and 1 P get involved and the other 2 P's don't get involved. So there we go. There we go. Beautiful. And this one is an SP hybrid. And these are 2 P's. This is a P and this is a P. In the case of carbon, it's a 2 P, and these are known as 2s3Ps, 2 sp2s, 2 Ps, 2 sps, and 2 Ps. There we go. So there you go. There are the 3 scenarios. That's all you can get. Okay. Now in class we did this, so I don't want to go over that again because that's kind of boring, really. But if it's sp, excuse me, around the carbon, if it's sp3, let me get a different color, you will get tetrahedral. Okay, so as the case we said above methane. If it's around the carbon sp2, you will get trigonoplanar. trigonal planar. Okay, and that's the C double bond, this thing. And if you get SPs, it's going to be linear. And it could be carbon dioxide, that's linear, or the nitrile, as I said. Oh, excuse me, I've got something in my throat now. I'm going to pause the video for 2 seconds. Okay, my computer went a bit weird there, but I'm back. So I hope that's fair enough. So there we go. So if you ever see a carbon with with 4 bonds coming out of it, let's do a different color. If you ever see this carbon here has 4 bonds coming out of it. Okay, all of them must be sp3. Every bond there is an sp3 hybrid orbital from the carbon. Now the hydrogen is going to contribute to a molecular bond of 1s. So the carbon hydrogen bond in this propane, is between the carbon supplies an sp3 and the hydrogen provides the s. So it's an overlap of sp3 and s, and obviously it's a sigma bond. Between a carbon and a carbon in this guy, one of these middle bonds, well, the one carbon must supply the sp3, okay, and the other carbon provides the sp3 as well. So in the carbon-carbon bond, it's an overlap of sp3, sp3. Let's have a look at the middle one. I've got this thing here. Let's have a look at, I don't know, methanol. There's methanol. I'm sure you've done this. Methanol is an aldehyde. All right, now the carbon. What's a carbon? Well, let's go through every possible combination here. All right, the carbon-hydrogen bond, there's 2 of those. And there's a carbon-oxygen bond, there's 1 of those. And there's another carbon-oxygen bond, there's only 1 of those. The carbon-hydrogen bond is a sigma. One of the carbon-oxygen bonds is a sigma, and the other one is a pi. Okay, we're talking about these things here. What is the hybridization about the carbon-hydrogen? Well, excuse me, if you look at the carbon, it has trigonal planar symmetry, or trigonal planar molecular geometry. So it must be sp2, coming from the carbon. Okay, now the hydrogen is going to supply the s, all right, one s orbital, and it's an overlap of an sp2 and an s. The carbon oxygen, well, the carbon supplies the sp2. Okay, now the oxygen, crazy but true, you don't have to know this, but the oxygen would supply an sp2 as well. You don't have to know that at this level, the hybridization of oxygen, how that does stuff. You don't have to know that, but it would. All right. Now, the other carbon oxygen would be between an S. Oh, what am I doing here? That's wrong. It's going to be, whoops, it's not rubbing out now. It's going to be between the P, the unused P, up here, of the carbon, and the unused P of the oxygen. So that supplies the pi bond there. All right, let's do this one now. The CN. This one's going to be a bit confusing, isn't it? Right, what bonds do we have here? Let's do the carbon dioxide. All right, there's going to be 1 carbon and oxygen, and another carbon and oxygen, and another carbon and oxygen, and another. There's 4 carbon-oxygen bonds now. All right, one of them, or 2 of them, I should say. 2 of them are going to be sigma, 2 are going to be pi in this guy here. The carbon, because it's a linear configuration now, will be sp and sp, all right, and sp and sp. All right, it's going to supply those 4. Okay, right, now the oxygen, one of the oxygens is going to be, let me think, it's an sp2, but you wouldn't have to know this about oxygen. The other oxygen, oh, I'm just realized I got something wrong. This is going to be sp2 as well, but you don't have to know that. All right, these, I got that wrong, didn't I? These are going to be between a P and a P and a P and a P. All right, I hope this makes a bit of sense anyway, but I don't know if it does. We'll see. Okay, so let me draw a weird molecule, and then I've got some questions for us. Okay, so let me draw a weird molecule. Let's do ethanoic acid. There's ethanoic acid. And let's try and do all the hybridization there. All the the bonds here. So this is a sigma. All single bonds are sigma. So that's a sigma. Now the carbon must be sp3 because it's 4 bonds coming out of that carbon. And the hydrogen supplies an S. So that bond is an sp3 S overlap. So is this and this. This middle one here is going to be one carbon. The carbon on the left is going to provide the sp3 because there's 4 electron directions around that one. But the one on the right, there's only 3 electron directions, so it must be sp2. So this middle bond here is sp3, sp2 overlap. One of these is going to be from the carbon sp2, okay? And the other, the pi bond, is going to be between a p and a p. Pi bonds are always between p's and p's. But the sp2 here, the sigma bond, is going to be between an sp2 from the carbon and the oxygen, that's going to be an sp2 as well. All right, you don't have to know the oxygen. I'm just telling you. All right. Now, let's have a look at this one. What's this one here? Oh, this is a bit awkward, isn't it? Let me try and draw it weird. What's this? Oh, the carbon supplies an sp2 because it's trigonal planar. And the oxygen in this case is an sp3. Okay. Now, why do I know this weird stuff? Well, the oxygen here looks like this. 1, 2, 3, 4. 1, 2. That's actually arranged in a trigonal planar, so it must be sp2. The one down here, it is 1, 2, 3, 4. 1, 2, 3, 4. This one actually is tetrahedral, so it must be sp3. And that's a bit technical. I don't know if you know that, but there you go. So that's how we determine what bonds are what. Now, before we do anything else, we can grab some images. Where's my desktop? There we go. Should be here. Question 1. Let's go over these. And this is what you got to know, guys. So don't worry. If you don't understand anything I've done, this is what you got to know. Let's pull this down. P, Q, and R have the molecular formula C3H6O. They're all structural isomers of each other. P and Q contain an oxygen atom bonded directly to a carbon atom that is sp2 hybridized. R contains an oxygen atom bonded directly to a carbon atom that is sp3 hybridized. Explain the meaning of the term structural isomers. Structural isomers. What is a structural isomers? First of all, what's an isomer? They are compounds with the same, and this is more molecular formula. They've got the same molecular formula, but different structures. Okay, in other words, the order of atoms is different in each isomer. Okay, now a stereoisomer has the order of atoms is the same. All right, it's the orientation in space that's different. So there you go. Not a great answer, but I'm sure that would give me 2 marks. Explain how the sp2 and sp3 hybridization can occur in carbon atoms. How do we get sp2? Well, if you remember, sp2 was this. We had an S and 3 Ps. And then sp2 was when the S, so let me get a nice colour here, one S orbital merges or overlaps, that's another word they often use, with 2 p orbitals. Okay, and we get an sp2. sp3 hybridization is 1 s orbital, merges, overlaps, I'm going to say merges, with, how many? I've lost there, with 3 p orbitals. Okay, and that's all they want. Okay, they want to know how it's made, how it can occur. Okay, and that's it, simple as. State the bond angles formed associated with each type of hybridization in carbon atoms. Right, if you've got sp2, as I say, it's always this. And sp3 is always this. Okay, so sp2 is going to be 3 bonds, 3 single bonds, and the 4th bond is going to be a pi bond. It's going to be something like that. This one down here, the sp3, is going to be that. So in an sp2, these at angles, this trigonal plane is going to be in 120 degrees. And this one, the sp3, is going to be 109.5. Okay, so there's that question. I've got a couple more questions, so I hope you get that one. Let's have a look at the next one. Where are we? Images, question 2. All right, this one looks nice, I think. Okay, all right. Never get phased by these. They're not hard, I promise you. This guy here is used in the synthesis of some antibiotics. What's it called? Right, first of all, we just draw it. So you've got a carbon there. You have CH3, CH3, CH3. That's that bit. That's that bit on the end. That's that bit. And then we have, oops, wrong color, but then mine. Then we have CHO. So that's what they want us to name. All right, so I'm sure you've done this in class, but obviously there's a 3-carbon chain there. So it's propan. It's an aldehyde, so it's going to be propanal. Okay. Now there's things on my aldehyde. There's methyl groups. We call this number 1. This is number 2, and this is number 3 carbon. That's not even in the right place. But this is number 3. So where the action happens is always number 1. This is number 1. So this is propanal. And there's a methyl on number 2, and there's a methyl on number 3. Sorry, methyl on number 2, and there's another methyl on number 2. So this is simply 2,2-dimethyl propanal. Okay, that's the name of it. Whoopsie daisy. So that's that. Oh, they've drawn it for us there. State the hybridization in the carbon atom with the asterisk. Now, how many electron directions are there? There's 1, 2, 3. All right. Now, therefore, very simply, it must be sp2 because this part of the molecule is trigonal planar. All right. These, since they're bonded to 4, even that one, all of these are sp3 hybridized because they're tetrahedral. Hope that makes sense. Let's go to the next question. All right, images, number 3. Okay, so this one is a multiple choice about hybridization. So let's see if we can figure this out. When considering 1 mole of ethene, so let's draw ethene. Ethene looks like this. Okay, it's pretty ugly, but there you go. Okay. Which row describes both the hybridization of the atomic orbitals in the carbon atoms? It's always going to be carbon. Always carbon. When we talk about hybridization at this level. All right. And the overall bonding. Okay. So, well, it's 3 directions here. It's not tetrahedral, is it? This is a flat thing. This is an alkene. So it's flat. So it's definitely going to be sp2. So it's that one or that one. Let's count out the bonding now. Well, how many sigma bonds are there? Single bonds are sigma. And double bonds, one of the double bonds are pi. So let's do the sigma first. 1, 2, 3, 4. One of those, 5. So there's 5 sigma bonds and 1 pi bond. There's the pi bond. Okay, there you go. So the answer is B. 3B. I hope that makes sense. All right. If it doesn't, give me a shout. Let me check this. 1, 2, 3, 4, 5. Yeah, that's correct. Okay. Now number 4. This looks like a weird one, but you never know. Each carbon atom in T, this is T, forms a sigma bond to at least one other carbon atom as shown. There you go. There are all the sigma bonds. Obviously, there's one missing, isn't there? That's the pi bond. So right in the middle. On the diagram, draw the orbitals that represent the pi bond that's also present in P. Now, whoops, there's going to be a nice dark color, this purple color. There's going to be a pi bond there. There you go. Beautiful. All right, there's the pi bond. All right, state the hybridization of the 2 carbon atoms between which the pi bond forms. Well, it's trigonal planar, isn't it? There's 3 electron directions, so it's going to be sp2. All the answers seem to be sp2, to be honest with you. Let's have a look at another one. And, oh, this is a bit of old school stuff. We don't have to do these anymore, do we? But let's see if we can do it. Which changes are commonly involved in the formation of a nitrogen polymer? Oh, let's have a look at that. This one. Why did I add this one? All right, I'm going to do a nice, easy one. Ethene. There's ethene. And I'm going to join it to another ethene. Okay, there we go. Okay, so these 2 ethenes are going to come together and it's going to form a polymer. 1, 2, 3, 4, something like that. And it's going to go on. And there you go, you get polythene. Okay. Alrighty, so we're good there. All right, the formation of a sigma bond. Yeah, sigma bond does form between this carbon and this carbon. There is a new bond formed there, and it is a sigma. How do we know it's a sigma? Because it's a single bond. The breaking of a pi bond. Yeah, one of these pi bonds breaks. That's what forms the sigma bond. Okay, one of the sigma bonds stays where it is, but the other one breaks. The pi bond breaks, and the electrons from here go there. So that is true as well. A pi bond is broken. The change in hybridization of the orbitals goes from sp3 to sp2. Actually, that looks pretty good to me, because in ethene, you've got 3 electron directions, so it must be sp2. All right. And in this guy, you have 4 electron directions, so it must be sp3. So this is good as well. So 1, 2, and 3 are correct. In the old days, we'd call that answer A. Okay. Now, please watch the video. Well, obviously, if you can hear me, you're watching it. But it is important you understand this. Eh? All right. I hope this helps, and I'll see you later.